Hello guys, today is our lesson about a significant feature of any electrical device. This feature sounds as uh, replacing any device uh, by equivalent circuit if voltage which included to this device outside the bandwidth of frequencies, which we can represent this element as simple or outside the bandwidth. uh, as a rule is frequency increases to higher side uh, by equivalent circuit. Okay, as as you see on the picture, uh, this picture exists from two parts. Left part is simple elements, and right part of the picture is their equivalent circuits. First, for resistor. Later we have the resistance element in any circuit as Russian style. This in the Russian circuits imagined as this picture. In the low frequencies or later the bandwidth, or in the bandwidth in which we should represent resistance as simple element, in the or for another in the uh, low frequencies or of voltage which included two contacts of resistor, uh, is simple resistor. And if we increase increasing this voltage, we must describe this resistor by equivalent circuit as writer here. On this circuit we see self resistor and it arose parasitic veils or parasitic elements such as capacitance and inductance with little subscriptor letter P. Okay, capacitance have arisen between contacts of resistor because with high frequencies arose currents of replacement between contacts of resistor. Okay, and as we know, currents of replacement are flowing in the capacitor, and erosion on the high frequencies have erosion electrical inductance on the resistor. Okay, and for capacitor, these parasitic veils has little veils because these little veils increasing as we increase frequency. For high we increase frequency. If we will be increasing frequency of voltage, these veils parasitic is increasing collaboratively. Okay, so equivalent circuit for capacitor. Capacitor is this element, this behaving as resistor similarly. Okay, on the high, low frequencies of voltage, if we include this voltage to contacts of this capacitor, we have simple element. We should represent we should represent this element as simple in the circuit. If we increase the frequency which include to capacitor, uh, we must imagine this capacitor no simple but is difficult as writer scheme. Okay, what what arises what arise on the scheme? Arise values as a resistor of parasitic, and we imagine by this resistor with subscript letter P, and parasitic inductance with parasitic letter P as subscript. Okay, resistance parasitic is resistance of dielectric. As we know, is the dielectric contents between plates of any capacitor. Uh, is resistance of this dielectric is non-ideal, as represents by RP or R parasitic, or resistance parasitic, and inductance as parasitic with subscript letter P has erosion in high frequency as inductance between contacts of this capacitor. As we know, all values non-ideal, and therefore arises parasitic inductance. Okay, for inductance, inductance is element of electrical circuit as represented by coil, which exists from wounds, wounds uh, wounded around the core of inductor. On the inductor in any frequencies, not necessarily in the bandwidth of frequencies, and significant becomes in the bandwidth, we must represent by their equivalent circuit. If it no idealized, okay, if inductance is idealized, we can represent this inductance by simple element, and if non-idealized, we must calculate it about, and with our calculations we must account to these parasitic values during our calculations. Okay, parasitic capacitance is a capacitance between wounds of wire from which exist the coil of inductance. Between these wires, isolated one from another, arises capacitance parasitic, of course. And parasitic resistance is resistance of any wire, any conductor, as we know, has parasitic resistance. Or it may be non-high resistance, very low resistance, but with if we conduct very exact calculations, we have to account this resistance. Okay, and I should mention about such significant future of circuits uh, electrical circuits maybe as concentrated parameters uh, with calculations of their circuits. And next point is sounded as electrical circuit with spread parameters. If concentrated parameters circuit described by ordinary differential equations and spread parameters circuit described as partial differentiation, partial differentiation equations. Okay, and and if who don't understand, uh, I ask you to write your opinion and write questions in the comments below, and subscribe my channel for discussed another futures of electrical circuits and maybe mathematical futures or graphical futures. Subscribe, write comments, and goodbye today.